Hello, everybody. We'll get started in a couple minutes with everybody coming in. I see the number keeps growing, so I'm pretty excited to get this webinar going. We have a couple hours for this, so a lot of good information. I'm John Nolte. I am the immediate past president of the GPN. Probably know a lot of you. I've probably seen a lot of your names. You might have seen my name. Wanted to welcome you to this incredible webinar. If you just go quickly through. I'll have a couple slides and then I'm going to turn it over to Joe. But this webinar is the Beyond the Buzzword, Understanding AI in Government and GIS. So artificial intelligence is reshaping how we work, communicate, and deliver public services. Yet many professionals still aren't sure what AI truly is or how to use it responsibly. This webinar demystifies AI and large language models through clear, practical explanations designed for GIS and public sector practitioners. We'll explore what AI can and cannot do, how it already appears in everyday tools, and where it can safely enhance geospatial workflows, communications, analysis. Participants will also learn about key risks, including misinformation, data privacy, ethical considerations, and gain simple guidelines for using AI effectively without compromising professional judgment or sensitive information. Whether you're just curious or already experimenting with AI, this session offers a grounded, approachable introduction that blends real-world examples, best practices, and few myth-busting moments along the way. So, fantastic subject, something that we're really focused on. I'm going to share my screen for the initial slides that we have, go through them real quickly, and then I'll turn it over to Joe. So again, welcome to the Geospatial Professional Network webinar today. We do have some upcoming webinars. So we have the MAPI Q&A Conference Edition on Wednesday, March 11th. This is also going to focus on some of the eSig awards that we've had, the Single Process System winner, King County GIS Center, Seattle, King County AI GIS Strengthening State Environmental Policy Act, and Response Letter Generator. So some pretty cool information there. We also have the Distinguished Enterprise System winner with the City of Midland, Texas, the Council Dashboard, and then Innovative AI Models for the Forecasting, Monitoring, Warning of Hazard Events Research Highlights from the University of Wisconsin. And the dates are there as well for those. The other upcoming events that we have are LEAP Conference coming up in the next week or so, March 3rd through the 5th. It's a virtual conference, so if you're able to go to that, it's an incredible conference. The GIS Valtech Conference, and that's in Mobile, Alabama this year from March 30th till April 2nd. And then we have the GIS Leadership Academy, June 1st through the 5th in Boise, Idaho. So real exciting about that too. We also have the Advanced GIS Leadership Academy. So all those folks that have taken the GIS Leadership Academy, the GLA, can take the Advanced GIS Leadership Academy. And what we do with that is we go into more details in those areas. So we really focus on a lot of the concentrated parts of the initial week, the GLA, and we bring it to those advanced topics. So it's another one that's really cool. And of course, the best event that we have this year, the GIS Pro in October, which we're doing in Milwaukee, Wisconsin. We're really excited about that. I'm excited to go there. It's going to be a fantastic conference. Of course, there's always the learning on your own time, where you can basically have your own schedule set up. It's in our the GPN, learn.thegpn.org. We have a lot of webinars that we're adding on a regular basis, the workshops, things like that. So please use that resource. We really want that to start growing. And then, of course, if you're not a member, which I'm hoping most of you are, or if all of you are, join today or renew your membership. And it's a great opportunity for networking. The GPN is such a great organization. I've been part of it for a long time. And like I've said, many of you already know me. But I would love for you to get involved. There's also other ways, if you are a member, to get involved in some of the committees that we do, some of the communities. Look out for more information about that as we move throughout the year. We're meeting on a regular basis to talk about how we promote some of that stuff. So you'll probably see a lot more coming out with that. But with that, I will stop sharing for me and I will introduce Joe. So Joe Lavoti II serves as Director of Geospatial and Information Technology for Union County, Pennsylvania. He is a working GIS and IT professional who spends his days managing systems, working with data, supporting staff, and navigating the practical realities of technology inside county government. Over the past few years, Joe has gone deep into understanding artificial intelligence, not from an academic or engineering perspective, but as a practitioner. He uses AI tools daily, experimenting with them in real world workflows, and regularly discusses their strengths and limitations with colleagues and other professionals. He is particularly interested in helping working professionals understand what these systems actually are, what they are not, and how to use them responsibly. Today, he'll share a practical, grounded look at AI in government and GIS from someone actively using these tools and asking hard questions about them. And Joe has already asked us that if you have questions, please put it in the questions and answers. We will monitor the chat, but it's easiest. We'll capture it in the question and answers. So if there's follow-up, it makes it easier for us to follow up with those questions. And I will be monitoring along the way. And Joe has said that as he's focused, I will raise my hand and interrupt at times if there are specific things about this. So with that, I will turn it over to Joe, and I want to thank him for being here.
Thank you, John. Make sure everybody can see my screen well enough. My name is Joe Lavoti II. I am the Director of Geospatial and Information Technology here at Union County. I've been in this position for approximately almost 2 years now, but I've spent most of my GIS career in the public sector. So, artificial intelligence has moved from research labs into everyday workflows, including government offices. In a very short period of time, tools built on large language models have begun influencing how we write, analyze, summarize code, and communicate. That shift creates both opportunity and risk. This session is not about hype. It is not about panic. And it is not a product demonstration. I'm not going to advocate for any product over another. What it is a practical examination of what these systems actually are, how they function at a high level, where they perform well, where they fail, why human oversight remains non-negotiable in public sector work. By the end of this session, you should walk away with clarity. What large language models can realistically do, what they cannot do, and how to apply them responsibly in operational government and GIS environments. This is about disciplined adoption, not blind enthusiasm. So I'm now doing this. So we're going to start, and I'm going to put myself way out there. One of these images is really me. The other was generated by an AI model. So take a second, think about it. Which one do you think is really me? Some of you might know me in real life. You might already know. Ready? That's not working. That's why. The one on the left is AI. The one on the right is actually me. And maybe at the end, somehow we could get a poll to figure out how many people got it wrong. I'm curious how many were actually fooled. But the one on the left there, the Sora image, was generated off of that image of me in real life. So if you got it wrong, just let that sit in your head for a moment. The model that generated the image on the left has never met me. It does not know me. It does not even understand what a human being is. It predicted pixels. That's it. It predicted what a face that statistically resembles Joe Lavoti should look like based on patterns it learned during training. The training obviously was the real picture of me. And if that surprised you, that's exactly why we're here today. Because AI is now capable of producing outputs that are not just convincing, but personally convincing. And convincing is not the same as true. And that distinction is the backbone of this entire session. So before we go any further, I want to be clear about the perspective I'm bringing. I'm not a machine learning engineer. I'm not training models. I'm not affiliated with any AI company. I'm a director of geospatial and information technology in county government. My world is enterprise systems, enterprise GIS systems, infrastructure, cybersecurity, data governance, policy implications, public accountability. In other words, operational reality. Over the last few years, I have deliberately pressure tested AI tools inside real workflows. Not casually experimenting, I use them to draft policy language, to create and verify SQL and Python and Java and Arcade, all of which I can't do. I use to rewrite public-facing metadata, summarize technical documentation for leadership, evaluate vendor claims, and yes, intentionally push the models till they break. I've seen them perform at a very high level. I've also seen them fabricate information with absolute confidence. So the lens I'm bringing today is not hype. It is not fear. It is guided and applied experience. The question we're answering together is simple. What are these tools genuinely useful in government and GIS work, and where must we apply discipline? So here's how today's going to work. We're going to break this into two major sections. First, we're going to understand AI, not the marketing version, not the LinkedIn version, the operational version. We're going to define some terms clearly. We're going to walk through a short history. We're going to explain how large language models are actually trained. We're going to talk about hallucinations and governance. And we'll talk about what happens to the data you type into these systems. I know that's something a lot of us worry about. When we put something in, what's happening after we hit enter? But before we use a tool, we need to understand it. I don't think anybody here is just going to go to a random power tool they've never used and not look at the instructions. Well, some of us might. So this may sound boring, but ultimately this is what we're here for, to learn what AI really is and to peek behind the curtain. In the second half, we'll get a little bit more tactical. We'll talk about where AI actually helps in GIS and government workflows, where it fails, how to structure prompts properly, how to integrate it into your work without removing the human element. And through all of this, one principle sits above everything else. Human oversight is non-negotiable. AI can accelerate thinking. It cannot replace accountability. By the end of the day, you should have a clear understanding of both the capabilities and the limits of these systems. And that's what responsible use requires. Here. The word AI has become almost meaningless. It's used to describe everything from spam filters to self-driving cars to ChatGPT. If Netflix recommends a movie, that's AI. If a model classifies satellite imagery, that's AI. If a chatbot drafts a memo, that's AI. Those are very different systems, very different architectures, very different capabilities, very different risk profiles. So when someone says we're using AI, the first question should always be, what kind? Artificial intelligence is an umbrella term. It refers broadly to systems that perform tasks that appear intelligent. It does not convey consciousness. It does not mean reasoning. It does not confer understanding. It simply means a system that can perform a task that if a human did it, we would consider intelligent. Today, we're focusing specifically on large language models, which are a very, very particular type of AI. And if we don't narrow the term, we end up arguing about completely different things without realizing it. So before we go any further, we're going to define these pieces clearly, because clarity is what removes the hype. So let's clean this up. Artificial intelligence is the umbrella term. It refers to systems that perform tasks that appear intelligent, things like classification, prediction, recognition, language generation. Under that umbrella term is machine learning. Machine learning refers specifically to systems that learn patterns from data rather than being explicitly programmed with rules. Instead of writing code that says, if X happens, do Y, you train the system on large data sets and allow it to learn statistical relationships. Then under machine learning is deep learning. Deep learning uses neural networks with multiple layers, which allows the system to model more complex, abstract relationships and data. Image recognition, speech recognition, and large language models are built on the same learning architecture. So when we talk about ChatGPT, Claude, Gemini, we're not just talking about AI in a vague sense. We are talking about deep learning systems trained at enormous scale. And that scale is what changed everything over the last decade. And that's where we're headed next. Generative AI refers to systems that create new content, creates text, images, audio, video. Unlike traditional software systems that retrieve information from structured databases, generative models construct outputs based on patterns they learn during training. They are trained on massive data sets. During training, the model learns statistical relationships between words, phrases, and structures. When you type a prompt, the system predicts what should come next. It doesn't look something up and doesn't check a fact table. It generates a response based on probability. That's why it can produce remarkably fluent and convincing output. It's also why it can be confidently wrong, because it's not optimized, because it is optimized for plausibility, not truth. It generates, it does not verify, and that distinction is critical and crucial both in GIS and even more so in government work. So, what is a large language model? It is a deep learning neural network trained on massive amounts of text data. What kind of data? Books, web content, articles, public documents. During training, the model learns statistical relationships between words, phrases, and sentence structures. It does not memorize facts the way a database stores records. It learns patterns. At its core, an LLM has a very simple objective. Predict the next token. We're going to get into tokens, so don't freak out yet. A token might be a word, part of a word, or punctuation. When you type a prompt into a system like ChatGPT, the model predicts the next most statistically likely token based on everything that came before it. Then it predicts the next one, and the next one, and the next one. That process, repeated thousands of times in milliseconds, produces fluent language. But here's the key. An LLM does not, quote, know anything. It does not understand truth. It predicts statistically plausible sequences of language. And once you understand that, a lot of its strengths and its weaknesses become much clearer. So why does this matter? Because if a system's job is to predict statistically plausible language, then its priority is fluency, not truth. It is optimized to sound right. It is not optimized to be right. That's why large language models can generate responses that are extremely confident and completely incorrect. They will produce an answer even when they don't have reliable grounding. Because silence is not an option. The model's objective is continuation. And when you understand that, hallucinations stop being mysterious. It's not malicious, it's not deception, it's probability doing its job. But in government and GIS work, plausible is not good enough. We deal in accountability, we deal in data integrity, we deal in public trust. So if a system is optimized for plausibility rather than verification, that means a human element cannot be removed. Let me say that again. That means the human element cannot be removed. Fluent does not mean factual. And that distinction becomes foundational for everything that follows. And I'm going a little off script here, and you guys are going to see, you're going to notice when I do that. Fluent does not mean factual. We encounter this every day in our lives when we just talk to somebody that we know is an absolute bonehead on a particular topic. They are fluent in English, but they are not factual in what they are talking about. That is the exact same thing about LLMs. They are fluent in our language, but they're not always factual. If you remember one sentence from this entire session, large language models predict the next token. That's it. They don't verify truth. They do not understand meaning. They do not reason like humans. They calculate possibilities, and they do it at enormous scale. That scale creates fluency. Fluency creates confidence. Confidence creates perceived authority. How many times have we heard people that we interact sound so authoritative, but as soon as you start fact checking, you realize, oh no, they don't know what they're talking about. I'm sure many of us on this call could definitely point out to a lot of people that fall into that category. So underneath it all, it is still prediction. And I'm going to reiterate this many times throughout this entire session. Once you understand that, the mystery disappears. Once the mystery disappears, discipline becomes easier. So, what is a token? Let's define that. A token is simply a chunk of text. Sometimes it's a full word, sometimes it's a part of a word, sometimes it's punctuation. The model does not see meaning, it sees tokens. For example, artificial intelligence is powerful. The model may break that into those individual words and seeing that the power is broken up from the full, because power could have several different things after it. So it is working at that granular level. When we say LLMs predict tokens, we literally mean, given the previous tokens, it predicts the next one over and over. That's how a sentence is built. Think about your predictive text. You are swiping, you're typing on your phone, and it says, oh, this is the next word. That is a LLM built in at a very, very basic level, trained on just basic sentence structure, the patterns. If I say on my, the next predictive word is likely to be way. That is a prediction model, and that's why we call it predictive text. But it is just a very, very small version of an LLM, because it's not reasoning, it's just predicting. It's continuing statistical patterns at the token level. Once you understand the tokens, the entire system becomes less mystical. It's math operating on chunks of text, not consciousness. All right, but you didn't know you were getting a little bit of a history lesson today. So AI did not appear in 2022. It did not begin with ChatGPT. The roots go back to the 1950s. In 1950, Alan Turing proposed what we now call the Turing test. The idea that a machine could demonstrate intelligence if it could convincingly imitate human responses. Early AI was largely rule-based, symbolic systems, if-then logic, heavy optimism. And then reality hit. The field went through multiple AI winters, periods where progress stalled and funding dried up because expectations exceeded results. I think another industry that many of us might remember in the early to mid 90s that had a lot of hype similar to AI, but it never took off, was virtual reality. I remember doing a research paper about that. I remember all the movies that were made about virtual reality, Lawnmower Man and stuff. And exactly what happened, the AI winter, there was so much expectation, but very little usable result at the time. And that's why it kind of died out. So fast forward to 2012, the ImageNet competition marked a turning point. Deep learning models dramatically improved image recognition accuracy. Neural networks trained at scale suddenly outperformed traditional approaches. That was a major inflection point. Then, in 2017, a research paper titled "Attention is All You Need" introduced the transformer architecture. That architecture made it possible to train models on massive data sets more efficiently. That is the technical breakthrough behind large language models. And then in 2022, these models became publicly accessible. ChatGPT put advanced language modeling into the hands of everyday users. It felt sudden, but it wasn't. It was decades of incremental research that finally reached scale. And that scale is what changed everything. So, we're not going to go through the entire history again, but I think there are a couple highlights we need to talk about for further understanding. 2012 was a turning point. The ImageNet competition that I referenced in the last slide was an annual challenge focused on image classification, identifying objects in millions of labeled images. When I say labeled, I mean humans had already tagged them. This is a dog. This is a traffic light. This is a bicycle. Think of it like attribute data for imagery. For years, improvements were incremental. Then a deep learning model called AlexNet entered the competition. It didn't just win. It dramatically outperformed everything else. And it wasn't a 1% improvement. It was a steep change. Error rates dropped by nearly half. And that's what got everybody's attention. So what changed? 3 things converged: deep neural networks, massive labeled data sets, sufficient GPU computing power to train at scale. GPUs are the heart and soul, the core. Without these advanced GPUs, we do not have AI as we understand it. We don't have these LLMs. That combination unlocks something powerful. For this audience, this lands pretty cleanly. We understand classification. We classify parcels. We classify land cover. We classify flood zones. ImageNet was essentially large-scale automated classification, but for objects in imagery. And here's something really interesting. Remember those select the squares with a bicycle captcha test? We've done those all the time. We still do them. You weren't just proving you were human. If you thought there was something more to that, you were right. You were helping improve image recognition systems. Millions of people labeling edge cases at internet scale. So what ImageNet proved in 2012 was this: when neural networks are trained on enough labeled data with enough compute, they can model extremely complex patterns. Image recognition improved first, then speech recognition, then natural language. Large language models are a direct descendant of that moment. 2012 proved that the scale works. And from that point forward, the trajectory accelerated. We know as anything tech, it does not grow linearly. It always grows exponentially. And we can see that in this graph here. So 2017 is where the real technological breakthrough happened. The research paper titled "Attention is All You Need" introduced something called the transformer architecture. So let's define that so we understand what that means. A transformer is a type of neural network designed to understand sequences, like language, by analyzing relationships between all parts of the sequence at once. Before transformers, language models read text kind of like a person reading one word at a time, trying to remember what came before. That worked, but it struggled with long-range context. If something important happened 20 words earlier, the model might lose a thread. Transformers changed that. Instead of reading in a narrow, linear way, they use something called an attention mechanism. Attention allows the model to look at the entire sentence or even the entire paragraph simultaneously and decide what matters. Think of it like this. Old models were like someone trying to follow a football play while only watching the ball. Transformers stepped back and watched the entire field. Who's moving? Who's blocking? Where's the coverage? What connects to what? That shift made large-scale language modeling dramatically and more efficient. It allowed models to scale, and scale is everything in this story. But here's the key. The architecture in 2017 didn't cause the explosion. 2022 did. That's when That's when large language models, give me 1 second. I just lost something. Oh, back one more slide. There we go. Sorry about that. But 22 is when the public could finally touch it. Architecture in 2017, public accessibility in 2022, and once that bridge was crossed, the acceleration became visible. So at a high level, and we're going to go into more depth with this, how are the language models trained? We've all heard about that. How are they trained? How do they do what they do? So this is not coding class. This is a mental model. Step one, collect the data. Large language models are trained on massive amounts of text data, books, articles, web pages, publicly available documents, licensed data sets. The goal is scale, billions and trillions of words. Step two, train the model. The neural network processes this text and learns patterns. It doesn't read like we do. It adjusts mathematical weights internally so that it gets better at predicting the next token in a sequence. If it predicts incorrectly during training, the system adjusts over and over and over and over and over and over. Millions of iterations. That's deep learning. Step three, token prediction. Once trained, the model's job is simple. Given some input text, predict what comes next. The quick brown what? Statistically, the next word is likely fox. Not because it understands foxes, but because it has seen that pattern enough times. Step four, repeat and fine tune. After base training, models often go through additional tuning. This may include human feedback, safety alignment, reinforcement learning, guardrails. This step helps shape how the model behaves in real-world case. But here's what matters to you guys. At its core, the system is learning patterns from data and optimizing token prediction. That's it. Massive data, deep learning, probability. Which leads to an important question. What data was it trained on? And what happens to the data where you put into it? And that's where we're heading next. So we were at a high level. Now we're going to get into a little bit more into the weeds, not too deep. Again, I'm not trying to teach you the foundations and how to train the model, but if you understand the higher levels of each step, it's going to make a lot more sense. So the first step in training a large language model is data, a lot of it. These models are based on massive amounts of text that include, again, publicly available text, licensed data sets, books, academic material, curated training corpora assembled specifically for model training. The goal is exposure to patterns at scale, not memorization. Pattern learning. The model ingests this data during training and adjusts internal parameters to better predict language sequences. Now, an important clarification. Training data does not mean the model has live access to the internet. Most models are not browsing the web in real time. They are trained on a snapshot of data. And before I go any further, understand this is the training of it. That's not saying that the ChatGPT or the Claude or the Gemini that you're using right now don't have access to the internet. We know it does. But when you're training it, when these models were trained, and some of us have heard, I remember a conversation yesterday in a meeting where when it first came out, it was a little bit behind because it was still in the training phase and it wasn't pulling from the current internet. But now that these models, when we had ChatGPT 1 and then 2 and then 3 and then 4 and then 4.0, 4 mini, 4 high, all those different models and all that. And that got really confusing because they were doing different things at different times. And now all these models are kind of grouped together. So most models were not browsing the web in real time during their training. Some systems layer search tools on top of them, but the core model itself is not looking things up unless that capability is explicitly integrated. And here's another key point. The model does not have a filing cabinet. Does not have a list of documents it pulls like a database. We're going to touch on that a little bit later. It doesn't look things up, quote unquote. It learns patterns from the data it was trained on. That distinction matters because if you train a system on messy, biased, incomplete data, it will learn messy, biased, incomplete patterns. We understand this in GIS. If your partial data is outdated, your analysis is wrong. If your flood layer is incomplete, your output is misleading. If your attribute table is dirty, your map lies confidently. AI is no different. It doesn't know what's right. It knows what's statistically common. So the data it learned from is skewed, that output will reflect that skew. And that leads directly to the next layer. How does it actually break down and process all that data? That's where tokenization and pattern learning comes in. So now we're going to get into the mechanics a little bit. I promise you not too deep. Before a model can learn anything, it has to break language down into pieces. As mentioned before, that process called tokenization. So when you type a sentence into a model, it's not saying language the way we do, it's saying a sequence of tokens. If you remember the previous slide, the way it broke it up. So think of it like GIS data layers. When we look at a map, we see roads, parcel, flood zones. Under the hood, it's geometry, coordinates, attributes. Language works the same way here. We see sentences, the model sees tokens. Now here's where the learning happens. During training, the model predicts the next token in a sequence. If it gets it wrong, it adjusts and it tries it again. And we said it happens millions, billions of times. It's like film study for a quarterback. You run the same read over and over until pattern recognition becomes automatic. Except instead of reading defenses, it's reading language patterns. Over the time, the model gets very good at predicting what usually comes next. Much like that same quarterback doing that same read over and over, he knows how people are going to react to that play in most of the time. But here's the key. It is learning statistical relationships, not meaning, not intent, not truth. Patterns. That's powerful, but it also explains why it can sometimes sound incredibly smart and sometimes completely off base because it's playing probabilities. And probabilities are not the same thing as understanding. And I know I've said about prediction and probabilities, and I'm going to say that many more times so that that really gets in your head. Prediction at scale. And this is where we get to the part that actually changed everything. At its core, the model predicts the next token. But here's what matters. Again, we said it doesn't do it once. It does it billions of times. All over the neural network with billions of parameters. When you type a prompt, the model generates one token. Then it uses that token to help predict the next one, and then the next one. and does that thousands of times in milliseconds, and that's why it feels conversational. That's why it feels fluid. But the real differentiator here is scale. Earlier language models existed. What changed was the number of parameters, the amount of training data, and the amount of computing power. Again, those GPUs are the lifeblood to AI. It's like the difference between a high school team running 10 plays and an NFL team with a full playbook and years of film. More exposure, more repetitions, more compute. The more patterns the model sees during training, the better it gets at predicting plausible sequences. And once you hit a certain threshold of scale, fluency jumps. That's what happened over the last decade. It wasn't that we suddenly figured out intelligence. We scaled prediction. And scale is what makes it feel intelligent. But remember, fluency is not understanding. It is very, very refined pattern prediction. Now we get to the part most people don't realize. After the base model is trained on massive amounts of text, it's just not released into the world. There's another layer. Reinforcement learning from human feedback, RLHF. Here's what that means in practical terms. Humans look at model outputs. They compare responses. They rank which ones are better, more accurate. Anybody that uses ChatGPT right now knows occasionally you're sitting there using it and it will generate two responses side by side and say, hey, which one do you like better? And you pick one. You read both, you pick one. It happens to me all the time. We are part of that human feedback loop. So we rank which ones are better, which are more accurate, which are helpful, which are safer, which are more aligned with the intended use. I put a prompt in and it gives me two different tones. And then I realize, okay, I like this tone better. And then as I continue to use that project in my ChatGPT, it knows I've given it more feedback so it can output, it's predicting what I want. And over time, that helps shapes its behavior and how it interacts with you. Oh, no. Okay. So that model is not neutral. It is shaped. It reflects decisions made by the humans training and tuning it. What gets reinforced, what gets discouraged, what gets filtered, what gets allowed. Those are human decisions. And that's important. Because when people say the quote, the AI said, they're skipping over the fact that humans influence how that AI behaves. The architecture learns patterns, but humans steer alignment. And that's where governance, bias, and oversight start entering the picture, which is where we're heading next. Talked about AI hallucinations. I thought this was kind of appropriate because I've seen some crazy hallucinations. So what is an AI hallucination? I'm going to give you a real world example first that illustrates exactly what we're talking about and why verification matters. Generative AI systems can produce information that looks legitimate even when it's completely made up. This has happened recently in professional settings, including the legal system. I'm sure many of you have heard of this case, and for those that have not, they're going to love it. In 2025, attorneys representing MyPillow CEO Mike Lindell in a federal defamation case in Denver used generative AI to help prepare a court filing. When that document was submitted, the court found nearly 30 erroneous legal citations and misquoted precedent, including references to cases that did not exist. Let me say that again. It included references to cases that did not exist. It made it up. During a pretrial hearing, one of the attorneys admitted that they had drafted part of the motion themselves and then ran it through AI, but did not verify any of the results before filing it with the court. A federal district judge, Nina Wang, ruled that the filings violated court rules because they contained misquoted and non-existent case law. The judge sanctioned the attorneys and ordered them to pay fines, in this case $3,000, for failing to verify the AI-generated content. This incident is one of the several documented cases where legal briefs drafted with AI contained fabricated sources, flawed citation, or invented legal reason. And courts have responded by warning attorneys that failure to verify AI-generated content can violate professional conduct rules. Here's the point. The model generated text that looked plausible, complete with legal citations and reasoning, but none of that information was checked against real case law. This wasn't malicious or conspiratorial. It's the statistical nature of prediction. The model produced language that matched patterns of legal briefs, even though the underlying facts were wrong. That's AI hallucination. It sounds authoritative, but it's not verified. And in professional contexts like law, GIS data interpretation, policy analysis, fluency without accuracy can lead to real consequences. So why? Why does AI sound so confident? So one of the reasons people get into so much trouble is it sounds confident. It doesn't hedge much. It doesn't say, I'm not sure very often. It delivers answers in complete, well-structured sentences. And that confidence can feel authoritative. But here's why that happens. The model was trained on massive amounts of human written language. And human written language, especially professional writing, tends to sound confident. Legal briefs sound confident. Academic papers sound confident. Policy memos sound confident. The model learned that pattern. So when it generates a response, it mirrors the tone and structure as seen during training. It's optimized for coherence. It's optimized to complete a thought cleanly. It is optimized to it is not optimized to self-doubt. And the most probable continuation of professional writing is usually assertive. Think about it like this. If you've ever watched a rookie quarterback throw a beautiful pass in practice, you know the arm talent is there. But reading the defense is different. Fluency is the arm talent. Judgment is something else entirely. AI has fluency at scale. It does not have judgment. So when it sounds confident, that confidence is not a signal of truth. It's a signal that the probability model is functioning correctly. And in government and GIS work, we cannot confuse tone with reliability. Confidence does not equate competence. That's why verification remains your job. So now you probably want to know what happens when you type into the system. When you hit enter, what happens to your data? Well, the honest answer is, it depends. It depends on the platform. It depends on the license. It depends on whether you're using a public web interface, an enterprise agreement, or an API. Some public-facing tools may retain user input for model improvement or logging, depending on the plan and the settings. Enterprise agreements often include data isolation and no training guarantees. API use can be structured differently from browser-based tools. Open source models, when deployed locally on your own infrastructure, never leave your environment, but they require more technical setup and governance. The key takeaway is this. You should not assume all models handle your data the same way. This is no different than any other software procurement design in government. You wouldn't upload sensitive parcel data to unknown cloud provider without reviewing the agreement. Same principle here, which leads to a very simple operational rule I follow. If you wouldn't send it in an email, don't paste it into a public model. Not because AI is inherently unsafe, but because governments and accountability still apply. AI is a tool, and tools exist within policy boundaries. Know the boundaries before you use it.
Hey, Joe.
Yes, sir.
There's a question in the chat that I think applies right to this section, so I was waiting to ask you. But
Absolutely.
Jonathan Levi has asked, or Levy, I'm not sure how to say it, but what is the best way to keep the prompts and results within the US? I am thinking about cybersecurity.
Um, that the only way to keep it in the US, in my opinion, would be if you had a localized model, an on-prem model, or you are working with a company locally, and you're not working with, you're not putting stuff into ChatGPT, Claude, even though they say they're local, they have their headquarters here. I cannot verify where all of their data centers are. So that being said, having it as local as possible would be the best way to ensure that on the cybersecurity issue. I hope that answers your question, sir. So not all access points are the same. And this is, I think we're going to get right to that right here. I got to click this. Public models are what most people are familiar with. Web-based tools, quick access, minimal setup, but control is limited. You operate under general terms of service. This is where you would find the most value, Jonathan. Enterprise models are different. These are contract-based agreements. They often include data retention limitations, administrative controls, compliance alignment, clear boundaries around training and use. In government settings, this is typically the appropriate path if AI is being formally integrated. Then there are open source or locally deployed models. These run on your own infrastructure. Nothing leaves your environment. You have full control, but you also assume full responsibility. Security, updates, model tuning, performance optimization. There's no vendor safety net. Think of it like hosting your own servers, your GIS servers. You gain control, but you also inherit that complexity. As control increases, responsibility increases. There's no free lunch here. Whichever path you choose, governance does not disappear. It just shifts. That's the pattern you should recognize. So, it is important to understand something very clearly. AI systems are not neutral. They are trained on human-generated data. That data reflects human behavior, human language, human bias, human error. Then after base training, humans step in again through reinforcement learning, through safety alignment, through guardrail design. Humans decide what should the model answer, what should it refuse, what tone should it take, what topics require filtering. Those are human decisions. The architecture learns patterns, but humans steer behavior. That means the outputs you see are shaped by the training data. The alignment strategy, the policies of the organization deploying the model. This is not inherently good or bad, it's just reality, but it matters. Because when someone says the AI said this, what they're really describing is a statistical model trained on human data and shaped by human decisions. In GIS, we understand this instinctively. Data isn't neutral, projection choices matter, classification choices matter, symbology choices matter. AI works the same way, which is why governance cannot be an afterthought. It must be a part of adoption. AI training reflects human decisions. Training data is human, alignment is human, guardrails are human. AI is more human than you think. The organizations building these models are intentional choices about safety, tone, and boundaries. And here's the important part. Not all organizations make those choices the same way. Different companies train differently. They align differently. They deploy differently, which means when we say AI, we're still being too broad. So before we talk about limits and principles, let's step back and look at the actual landscape. Who is building these systems and what are the trade-offs between them? Quick little funny haha here. No, ChatGPT cannot write original code because it still needs the parameters. But then again, neither can I. I can give ChatGPT the parameters I need and it will spit it back to me. So let's talk the major model landscapes. We're going to zoom out a moment and touch base on some of these models that we've all seen and explain a little bit about them. So not all large language models are the same. Different organizations are building different systems and they have different priorities. OpenAI builds the GPT class models that many people interact with directly. Strong general reasoning, multimodal capability, and broad enterprise presence. Anthropic builds Claude. Their positioning emphasizes safety, long context reasoning, and structured responses. Google builds Gemini, deep integration with search and their ecosystem. Microsoft doesn't build its own frontier model from scratch, but it embeds AI deeply into enterprise workflows through Copilot. Then there's Meta and the open source community. Models like Llama can be deployed locally, customized, and run on private infrastructure, but they require more internal capability. There are many other models out there as well, Perplexity, DeepSeek, Mistral. Here's what matters for you though. There is no single AI. There are models with different strengths, different governance approaches, different alignment strategies. Think of it like GIS platforms. Even though we're very limited, they have different tools, different architectures, different use cases. Choosing one is not just about performance, it's about integration, policy, data handling, and oversight. And this is where discipline matters, because once you understand the landscape, the next step is understanding what these models' strengths and weaknesses are. So we're just going to run through some of these real quick. I'm just checking my time here, okay? So let's start with OpenAI's GPT class models. It says many of you, if not all of you, have interacted with them in some form. But let's define something real quick. GPT, generative pre-trained transformer. And I'd be willing to bet of the however many people we have in here, probably 90% of the people did not know what GPT knew. And until I started doing my deep dives, I had no idea. Everything was ChatGPT. Generative, it creates new content. Pre-trained, it was trained on large data sets before you ever used it. Transformer, it's built on the transformer architecture we talked about earlier. That's it. No hidden meaning behind that. It's just a generative model. I just want to clear that out in case anybody was curious. Strengths first. Strong generalists, handle reasoning well, can generate structured writing cleanly. They work across modalities. This is important: text, images, code. They've been widely adopted, which means integrations are mature and documentation is strong. Enterprise versions exist, which make formal adoption viable in government settings. Now the trade-offs. These models are black box systems. You don't see the training data. You don't see the internal weights. You operate within the vendor's roadmap. That's not unusual, but most enterprise software works that way. But it matters. And also, this is important. They are generalists. They are not GIS domain experts. They do not understand your local parcel schema. They don't inherently understand your zoning ordinance. They can assist. Think of it like hiring a very smart intern that can draft, research, and scaffold all at the same time. So, next up, Anthropic's Claude model. Claude is known for handling long context well. That means you can feed it longer documents, policy drafts, reports, contracts, and it tends to maintain structure and coherence across larger inputs. I've experienced that with ChatGPT. Some really long documents get truncated. So you have to break it up in order for it to get the full picture. It's also strong at structured output. You ask for an organized analysis, bullet breakdowns, or risk summaries, it performs well. Positions itself as safety forward, so you'll often see more cautious responses. The advantage is alignment and guardrails. The trade-off is that it may refuse tasks more often or be overly conservative. Claude, like GPT, is still a generalist. It does not understand your local environments unless you provide that context. It's not reasoning, it's only predicting.
So there is another question in the chat. Thad has asked about Anthropic, so I'm bringing this up now. Is what about Anthropic dropping its safety protocol recently?
That is of concern because, and we're going to get to Grok in a moment. So I'm going to put that one on the back burner and see once I get to the Grok portion of this, that answers the question. So next is the Google Gemini. Google's major advantage is integration. Gemini, for anybody that's a Google shop like we are here at this county, it's in there everywhere. And we have to go in there and turn it off for some of the staff that are not allowed to interact with the AI due to some of their state affiliations. So it connects with your Docs, your Gmail, your Drive, your Workspace. It also leverages search integration in ways that can improve grounding when enabled. That's important. When a model has access to real-time retrieval or search tools, it can reduce hallucination risk because it's not relying solely on pre-trained patterns. But that's layered on top of the core model. Underneath is still a transformer-based probabilistic system. The trade-offs. The more integrated a model is into an ecosystem, the more you're committing to that ecosystem. Alignment choices reflect Google's internal policies. While search integration helps, it doesn't eliminate the need for verification. If anything, it can create a new challenge. When generative output and search results blend together, users may assume everything is verified, but the underlying engine is still predicting tokens. Let's talk about Copilot real quick. Copilot is less about building a frontier model from scratch and more about embedding AI into tools organizations already use: Word, Excel, Outlook, Teams. Instead of going to a separate AI interface, the assistant lives inside your workflow. For government organizations already operating heavily in Microsoft environments, that lowers the barrier to entry. There's also enterprise governance alignment, which matters. But here's caution. When AI is embedded directly into productivity tools, the friction to use it drops dramatically. That can be good, but it can also create over-reliance. If you're drafting a memo in Word and Copilot generates the first draft, it feels seamless. But seamless does not mean verified. It's still generating statistically plausible text. It does not understand your local ordinance. It does not understand your internal policy nuance. It is still predicting language. Open source models, Llama, Mistral, they are different from GPT and Claude in one key way. You can run them yourself on your own infrastructure, inside your firewall, nothing leaves your environment. From a governance perspective, that's appealing, especially in government settings where data control is critical. You also have the ability to fine-tune them, adjust behavior, customize outputs. But here's the trade-off. When you take control, you also take responsibility. You are responsible for security, updates, infrastructure, alignment decisions, performance optimization, guardrails. All of that is you. As I said before, there is more human in the AI than you realize. So when it comes to which one you want to use, do you want maximum capability? Do you need maximum control? Those are decisions you have to make. Here's something that's going to really tickle us: the Esri GeoAI. GeoAI is focused on spatial machine learning, classifying imagery, extracting features, running predictive models on structured spatial analysis, structured spatial data. That's quantitative. That's spatial modeling. That's pattern recognition and raster and vector data sets. Large language models, everything I just talked about, they predict patterns in text. They generate content. They summarize documents. They scaffold the code. They assist with communication. They do not understand geometry. They do not understand topology. They do not calculate buffers. They can help you write the script to do those things, but they are not doing the spatial modeling themselves. Think of it like this. GeoAI is like running spatial analysis in Pro. LLMs are like having a drafting sitting next to you while you do it. Different tools, different purposes. So by now, you may be wondering, why haven't I talked about Grok? This is a case study in governance and why oversight matters, Grok in particular, and given the question in the chat, Anthropic. Grok, developed by XAI, has faced public scrutiny regarding model behavior, moderation, consistency, and alignment decisions. There have been concerns raised about output bias and guardrail inconsistencies. There have also been broader investigations reporting around XAI's operational governance. Now, here's the point. The point here is not partisan commentary. The point is structural. AI systems reflect the organizations that build them. They reflect the training data decisions, the alignment strategy, content moderation, leadership philosophy, oversight discipline. When governance is inconsistent, outputs become inconsistent. When alignment is unclear, behavior becomes unpredictable. This is not unique to Grok. It applies to every model, to Anthropic as well. They've taken off some guardrails. Some organizations are very transparent about guardrails and safety processes. Others are less so. If we're using AI in government and GIS context, where public trust matters, governance cannot be an afterthought. The architecture may be similar across models, but alignment decisions vary. And that's why we evaluate tools not just on capability, but on oversight, because models reflect the humans and the policies behind them, always. All right, so let's reset some expectations. I've given you some history. I've given you a lot to think about here. So what AI is not. AI is powerful. You saw the sentence I put up there for the token. But it is not what many people think it is. So let's be clear. It is not intelligence. Just because that word is in this title does not mean it is intelligence. It is not reasoning. It does not think. It does not understand context the way you understand context. It is not a database. When you ask a question, it is not retrieving a verified answer from a structured system. It is predicting language. It is not a decision maker. I'm going to say this again because I know nobody on this call has done it. Wink, wink. I hope nobody has. It is not a decision maker. It should not be determining policy, approving budgets, interpreting law, or validating data sets. It is absolutely not a replacement for domain expertise. It does not know your ordinance. It does not know anything about, it does not inherently know what you know about your local everything because it was never trained on it. It predicts patterns. That's it. And once we stop assigning it qualities it does not possess, we can start using it responsibly. AI is a tool, not authority. That distinction keeps you in control. So let's separate some terminology from reality here. We call it artificial intelligence, but that phrase does a lot of heavy lifting. It does not have awareness, no intent, no understanding, no judgment. It does not know that a statement is true. It predicts the patterns in data. I've said this so many times in this presentation, and I will say it many more. If you ever run a regression model, you understand this instinctively. The model can produce statistically strong correlations, but it doesn't understand the variables. It doesn't understand consequences. It doesn't understand context outside the data it was trained on. Large language models operate the same way. They are extremely advanced statistical systems. Calling it intelligence can trick us into attributing qualities that simply aren't there. It's like calling a calculator mathematically reasoning. AI is not intelligence, it's pattern prediction at scale. So, AI is not A database. We all understand databases. And GIS is core to what we do. We work with structured data, parcel tables, address points, zoning codes, attribute fields, relational joins. When you run a SQL query against a parcel data set, you might get deterministic output. If the record exists, it's returned. If it doesn't, it's not. That same query tomorrow produces the same result. That is not how an LLM works. It does not have a table of verified records it's querying. It doesn't have a structured attribute table it's referencing. It can't run select statements on the training data. That means it may produce slightly different answers to the same question. It may fabricate something that looks like a record. It cannot guarantee repeatability the way a database can. Think of it this way. GIS database is authoritative storage. An LLM is predictive generation. Completely different systems. If you treat an LLM like a database, you will eventually get burned. If you treat it like a drafting assistant, you'll use it appropriately. LLMs generate, databases retrieve. Again, this is another key point to make sure we understand this. AI is not a decision maker. Let me say that clearly. It does not hold accountability, does not understand consequence, does not weigh political risk, does not consider public perception, it does not understand legal exposure. It generates suggestions. It does not make decisions. So think about a quarterback, awesome arm. He can throw the ball 70 yards. He's watched a ton of film, recognized the patterns, but he's still on the sideline. He's not reading the stadium. He's not feeling the pressure. He's not accountable to the scoreboard. That's you. You're the one on the field. You're the quarterback that is seeing the field. AI can suggest a play. It can recommend a route. It can draft a strategy, but you're the one who decides whether to snap the ball. Same in basketball. A data model might tell you a three-point shot has a higher expected value, but it doesn't see the defender closing out. It doesn't feel the momentum shift. It doesn't know who's in foul trouble. Context matters. In government and GIS, context is everything. AI can assist with analysis. It can summarize options. It can outline pros and cons, but the decision-making still belongs to a human being with accountability attached. AI assists. It does not make the decision.
Hey, Joe, another question here from Nathan, coming all the way from New Zealand too, which is great.
Oh, wow.
Yeah. There's a lot of hype in the media about AI replacing all or most white-collar jobs. You have mentioned many times that there needs to be a human in the loop and that AI is simply a tool. What are your expectations around this? If there are going to be job cuts in the GIS industry, then what skills do you recommend that GIS professionals should develop to protect their careers?
White collar jobs are going to be the hardest ones, in my opinion, to replace with AI. Because as I sit here as a director, I have to make decisions. I use the AI. It's like, okay, I have these two competing contracts. There's a lot of stuff in there. Analyze this and that. I can use the AI as a tool, but the decision still has to be made by me. I have to justify that. In order to protect our jobs, and this is a conversation I've had recently, we have to look at our interns differently. We can't treat our interns to do all the crap work anymore because AI can do that in a fraction of the time. So we, as bringing the interns in, need to think outside the box. They're going to use AI. How are they going to use the AI? Your skill set is going to depend on how well you use AI. If you are more on the coding side, you're going to want to really get into Claude because it has got a better coding engine than ChatGPT. If you are going to do a lot of policy analysis and policy drafting, you become good at prompting and refining your iterations. And we're going to get into some of those skill sets here shortly. I don't see white collar jobs. I see all the hype and everything. At the very, very base level, the amount of computing power required for AI to take our jobs just isn't there. We cannot scale that right now. we're already losing that because they're cutting chips for regular commercial production. I've got a lead-in time of 2 months for two tower systems that would have been $2,500 a piece last year, and they're now $5,000 a piece because of the cost of the chips. Cost. And it is a very volatile market, which I'm not going to get into in this presentation here, but AI is not going to take over our jobs, our white collar jobs right now. But if you don't get versed in it, you're going to be at risk of being left behind to those that are good with it. So, as I've said, AI is not a substitute for domain expertise. Doesn't know your local data schema, parcel schema. I need to move this along a little bit. You have to be the SME at all times. And one of the biggest things I have said, you have to QC the AI. And that's part of the reason, Nathan, that our jobs are not going to go away the way they're sensationalizing everything is because we still have to keep a human in the loop to QC it because it is not intelligent. Just because it has access to all the information in the world, it's not intelligent. We all have access to the same information it does. It just predicts the answers better than we can and faster. So, principle number 1, QC the AI, human in the loop. I stand by this. AI generates, you validate. It suggests, you confirm. It drafts, you own it. If your name is on it, you better QC it. I don't care how much AI you use. You need to make sure you validate everything. And my second principle, I didn't put these on as, to slide in. I want everybody to see this. This is extremely important. Don't put PII into public models. Protected personal identifying information. Birthdays, social security numbers, anything that would be a HIPAA violation. All of that stuff. We have, you see at the bottom, that's our disclaimer. Almost all of us have that kind of disclaimer in our professional email. So if you're not going to put it in the email, don't put it in here. Yeah. And that's why. So we all know that our data, all of it that's out there has already been compromised. Don't help them out anymore. Automation bias. This is where we have a tendency to trust machine output too much. And it's not new. We've seen it in aviation, healthcare. We've seen it in navigation systems. When a system produces outputs that look structured, clean, and authoritative, our brains relax a little bit. We assume the machine did the math because large language models amplify this effect because they don't just output data, they output polished language. It feels great. It feels correct. And that's the trap, especially under pressure. If you're drafting a memo, responding to leadership, preparing a quick summary before a meeting, and the AI gives you something that looks ready to send, your guard drops. That's automation bias. The accountability still remains with us. And fluency can lower skepticism. So when it creates that polished draft, and you're like, oh yeah, I'm going to send that out to my commissioner, and then you reread it later, it's like, oh no, that was not right at all because I didn't check that. So we know about garbage in, garbage out. AI reflects the data it receives, and it can amplify it. If you give an LLM flawed assumptions, it will build on it confidently. If you give it incomplete data sets, it will summarize them as if they are complete. If you give it bias training, it will produce bias analysis. And because it's fluent, the output can look extremely polished even when the foundation is weak. Let's ground this to something a little real. In 2012, Apple Maps launched with major geospatial data errors. I'm sure many of us remember that. Mislabeled locations, distorted geometry, misplaced landmarks. The issue wasn't the rendering engine. It was the underlying data quality and incomplete validation. Scale amplified the problem. Now imagine layering generative AI on top of flawed spatial data. If your address point layer has inconsistencies, your parcel data has outdated attributes, it's going to produce a flawed, confident answer because the fluency masks the foundations. Bad inputs don't stay small, they scale, they amplify. AI in government. Many of us work for government or some quasi-government affiliates. In the private sector, mistakes cost money. In the government, mistakes cost trust. Public trust is not transferable. You cannot delegate it to a model. If a memo goes out with incorrect information, the AI doesn't take the call from the commissioner. The human does. Accountability does not shift to software. It stays with the person whose name is attached to the work. And that's why we have to be careful about language. Outputs are not official positions. They're drafts. They should always be drafts. You still need to keep an eye on it. Oversight is a governance requirement. We have to have oversight. That is just, everything's oversight in government. There's audits, everything. So our software has to have that same oversight in governance. Human review is inherent in our industry. We all have QA and QC processes for various things that we do. Any output that any map we make we QC, we put eyes on it. Anything that comes out from AI needs to do the same. The tool assists the human answers. And as long as we keep that relationship clear, AI becomes a productivity asset. If we blur it, it becomes a liability. All right, I'm going to skip ahead a little bit here. We'll just throw this on here. This is the last part, the last slide before I get to a little bit more fun here. Input, output, accountability, all this stuff is at the forefront of why we are using and how we are going to use the AI in our spheres. All right, let's have some fun. I think I've thrown on the boring stuff. Let's talk about some other things. We've talked about where it can go wrong, accountability, discipline, what it really is and isn't. It's not magic. It's not intelligence. It's not authority, but it is powerful. So let's talk about how we use it well. And yes, this is an AI-generated image that I had Shora create for me. So what is it really good at? Whole bunch of stuff. I've said, so much about how we need to stay in the loop, but I want to tell you, I used AI a lot for this presentation. When I came up with the idea and I'm sitting there and I drafted, I didn't say, make me a 2-hour webinar about yourself, about AI. That would be completely irresponsible. What I did do is like, hey, I want to do a training session for these type of people concerning AI, this. And then I had so much back and forth. If I had structured this a little bit differently, I would do a live demo. I'll just show you like the long chat. I mean, it'd be a ton of paper if I printed everything out, just all the back and forth. I got to have a conversation with myself working with this, somebody that knows some of those things I can't do. I'm not a great writer of eloquent messages or scripting or anything like that, but I can use that AI to help me draft good things, review it. Oh, no, that doesn't quite sound like me. Let me put in my tone. Even when I work with the AI, it's like, put this in my tone. I read it. It's like, no, this sound like a computer. I need to take that out and I massage it. So yeah, this is how I would say it. Because the AI is predicting formal language. I don't speak formally. Y'all haven't figured that out yet. And it is an iterative process. And that is what makes it so good, because it is iteration at speed and scale. You can throw a whole bunch of things and you can shift gears in that same conversation and it doesn't miss a beat. It doesn't break down. It's like, oh no, dude, I got to jump back because it does that so well. What AI is bad at. We've covered a lot of this already, but just there's a nice little list there, AI in general, not the individual models. So we won't, that's there. AI is an accelerator. It can speed up the drafting. It definitely reduces cognitive load. Like you have an idea and you want to expand it, expand the ideation. I have this idea. And when it makes suggestions, you can have it interact with you in a particular way. It's like, okay, I want you to act as, and we're going to get into some prompt engineering here. Let me see. Okay. Yeah, okay. So it increases the speed. Down there at the bottom, it says humans provide direction. A car can't drive itself. It is a phenomenal tool. It can go as fast as you want it to or as slow as you want it to, but you still have to drive it. The AI is the same thing. So here's how I'm here to help you. Now that we've gone through the history lesson, let's figure out how we can actually use AI a little bit more day to day. Define the objective. What do you actually want? A summary, a rewrite, an outline, a code scaffold, a brainstorming session? Be specific. If you say something, write me about zoning, you'll get something generic. If you say draft a one-page memo summarizing the implications of updated floodplain ordinance for township supervisors, now you've defined the objective. You have to provide context. It performs better when it understands boundaries. Who's the audience? What is the tone? What level of expertise? What format? If you don't provide context, it defaults to generic internet tone. Set constraints, length, structure, tone, citations required, plain language only. Constraints will improve your quality immensely, but it does not have that built in unless you tell that. Review and verify. Non-negotiable. Absolutely non-negotiable. Check the citations. Read every word. Check the claims. If I ask the AI, hey, did Mike Lindell use that? And it said yes, and I don't check that and come find out, no, that was some made up internet story. I would have just been I didn't verify that. However, that is something I did know, and I did verify it before I put that in this story or in this presentation. But you still have to double check. This is your QC step. Refine iteratively. Do not accept to put the first draft. Push it. Make this clearer. Reduce jargon. Add local context. Shorten by 30%. It is a back and forth. You will do a lot more reading than you will actual writing. Direct it. Don't delegate to it. So write something about floodplain regulations. If that's your prompt, it's going to give you something, but it's going to be so generic. Now, if you say draft a one-page memo for township supervisors explaining the recent floodplain ordinance update, use plain language, highlight operational impact, and include a short bullet summary at the end. Clear objective, all that stuff is set up. I have a ChatGPT project whenever I got to do memos to my commissioners. One's a farmer, one comes from the energy sector, and one's a professor. So I have to create memos and things to appeal to all of them. And I define that in my instructions. Make sure that this reaches all three of these different types of people. And that helps me come up with a very clear, concise message that all three of them can understand well, much better than I would have come up with on my own. Quick point of order. If I get kicked off here because my computer's screaming at me for a reboot, I will be up and running in really quick. I'm hoping it doesn't actually reboot. So structuring prompts. Role, task, constraints, output. What is a role? Who is the AI acting as? Act as a marketing professional. I want to develop a marketing package to sell, my own little business. I need some commercial ideas. Give it the task. What exactly do you want it to do? The constraints. This is where you dial in and get everything set up so it is really reflecting what you are seeing in your head. Because remember, if you don't tell it, it doesn't know. And then what is the output? How should it be structured? Do you want it in bullets? Do you want it in a paragraph? Do you want fluff in there? Do you want, there's all these different things depending on the nature of the output. What do you need the output to be? So here are some examples, that should resonate with us. We all do metadata. We write it correctly. It includes references to ETL processes, internal systems, synchronization workflows. But when we put it out there for the public, they don't know what the heck that means. They don't care. What is this? How current is it? How accurate? Should I rely on it? This is where the AI shines. It takes that original partial boundary layer derived from county camera system, translates it into something much more easily digestible, even for us. I love that aspect of it. I can take a lot of jargon. I'm still learning stuff in my current role as IT director. I use the AI. It's like, oh, sum this up. I get these newsletters. I've learned, like IP versus TCP protocols and all these different cybersecurity things that is new to me. I can have it sum it up in terms I understand. Some of the sports analogies, I saw somebody mention something about that. It goes over their head, except for the sports analogies. I tell my AI when I put stuff in it, I wanted to explain it to me. Give it to me in my language. Give it to me in GIS terms, or give it to me in football terms, or some other related sport. Policy language. I work with other departments in helping they have old, outdated policy. That's you have weak instruction, write an AI policy for our county. Structured instruction, draft a one-page internal policy outlining acceptable AI use for county employees. This, that, and the other. I've worked with some other departments. They need to update their policies to current standards. So we take their current policy, the current standard, throw it into the AI, stripping it out of any pertinent information. It's like, make sure that our current policy matches, the state standard. And then they say, oh, I did an evaluation of all the policies for the one department, and it said it even identified the gaps from the state policy that the county was missing, so they could write their own. They didn't realize the gaps they had or the overlap that they had. So it really allows it to sit close. It really allows you to see things much quicker than you ever would on your own. You could see it, but it'll take you days as opposed to hours. So another example that I'm sure all of us are very, very familiar with. I use this extensively. I do not know arcade. I'm too stupid for coding. I've given up. I got way more things on my plate. I'm not going to learn the actual nuance. I know just enough to know what code can do. And I have used code. I recently created a dashboard, and I'm like, I want this to turn red if the condition is poor on one of the cards. And I gave it a screenshot of the arcade dashboard, and it's like, okay, you're doing that. Boom, gave me the code. I put it in, worked instantly. If it doesn't work, you paste that in there. It's like, what's wrong? I built a whole Visual Basic form program to track things, and I used a lot of AI to refine my Visual Basic code so that it performed what I did. It's like, oh, I have an error. I screenshot the error. It's like, oh, no, you messed up here. Oh, thank you, Mr. ChatGPT. So this, using it, plug your code in, say, hey, it's not working right. It's not returning. And you'll see the code like, ah. But remember, it's only the code that you're sharing with it. If it's reliant on other code, it can't see that. So you have to make sure you define, okay, I have a code coming from or an input coming from another code. Is that input affecting that? And then you may have to trace it back, but you can dial that in much quicker than trying to read 1,000 lines of code. Using AI and GIS workflows. I mean, this right here, if there's a takeaway screen for everybody for practical use, this slide would be it. There's so many different things on here because it is so general and it can do so much. You can use it in all these capacities. I'm not going to sit there and read everything. I'll give you guys a moment. I mean, I know personally, some of the things I've used it for. Brainstorm project approach. This whole presentation was brainstormed using ChatGPT. I've done up memos. Hey, I need to draft a memo about this, or here's the parameters of this thing. Write me a memo, and then I read it, refine it, and everything from there. Documentation is great for that. You could put in a whole bunch of scattered notes, and it can organize them for you. You could take screenshots and stuff, and it's getting really, really good at reading text, even some cursive. Now, if you write like me, it's going to have problems, but in general, neat writing, it can read that as well. And then you could screenshot your notes and get it organized so much better. That's one way to, I mean, this is just a small snippet. If you just think outside the box that wee bit, you do so much with this. Let's see where I'm at, slide 57. Okay. Now, this is the one thing that we do have to make sure that when we are using it, we are using it responsibly. And for those of us on the call that are in the public sector, there's a little bit more governance and oversight that we have to be mindful of. As I said before, public trust is the foundation of what we do. They don't trust us. They're not going to, use the information, use the product that we provide. It is the currency we operate in. Responsible adoption means transparency. If the AI is used to draft language, summarize analysis, or assist with documentation, that's fine. And it should be labeled as such, AI assisted or AI generated. But the human must review, and authority does not transfer to the AI. Data governance extends to AI now. We have our own data governance and the things that we do to keep track of our data. Now, if we're using AI, we have to manage that as well. It extends to the tools. Where data goes matters. How it's processed matters. And who is accountable matters. And this is where speed becomes a risk factor. The automation bias that I spoke about earlier as well. AI increases speed dramatically, but in public sector work, speed must never outrun accountability. We don't skip QA because the tool is fast. We don't bypass policy because the draft was generated quickly. Innovation is good. Innovation without oversight is not. I think I'm going to get booted here in a moment. So, in government, authority comes with responsibility. Uncle Ben said it great. With great power comes great responsibility. And AI, as we have seen, is extremely powerful. So if you're working on establishing an AI policy internally, you need to define acceptable use. It doesn't need to be 30 pages long. It needs to codify discipline. Be clear what the AI is for. Is it drafting, summarizing, scaffolding, and be clear what it is not for. Autonomous decisions, unreviewed publication. Second, establish the boundaries. Explicitly define PII restrictions. Clarify public tools versus enterprise tools. Remove ambiguity. Mandatory human oversight. This is, again, I've said it at least 4 times. This is non-negotiable. The human must stay in the loop. Provide training. We wouldn't deploy an app or any of our GIS software or any of the other software without training the end user. So if you are adopting an internal policy, you need to train people on AI, like today, what it is, what it isn't, how to use it responsibly and properly. And then review and update. Policy always needs updating and review. So, what should we walk away with today? We've covered a lot. If you remember nothing else, remember this framework. Capabilities, limits, discipline. AI has real capabilities. It drafts quickly, summarizes efficiently, it structures thoughts, it translates technical language, it accelerates thinking. Used correctly, it saves time, but it has limits. It does not verify truth independently. It does not understand your local nuance. It does not carry accountability. It predicts patterns. It does not exercise judgment. And that's where the discipline comes in. QC the AI. Follow the email rule. Apply the governance filter. Input, output, accountability. Remember that you are still the subject matter expert. The model assists, you own the outcome. When you understand capabilities and limits together, discipline becomes natural. And that's how you use AI without surrendering controls. So, we've talked about what AI is. We talked about what it isn't. We've talked about governance, discipline, accountability. Here's the reality. AI is not magic. It is not intelligence. It is not authority. It is prediction at scale. And that's powerful. When you combine that power with your expertise, it becomes leverage. It drafts faster. It structures better. And it reduces cognitive load. It accelerates thinking. But it does not replace you. And that, to your point, John, it will not replace you as long as you still hold the context, the judgment, and the accountability. In government work, supervision isn't friction, it's responsibility. Powerful tools still require supervision, and now you understand this tool well enough to use it intelligently. Not fearfully, not blindly, intelligently. That's the difference. I thank you guys for your time. At the end of this slide deck, I'm going to get rebooted here in just a moment, so I'll show you guys real quick, and I'll jump right back on. I have some definitions. And
so if there's some that put it in chat, this might be an answer that could be used for some of the folks that are on here as well. And so there was a question that says, anyone used AI for geocoding addresses and rematching without creating models? So I don't know if there's other folks that are on that can maybe answer that they're using AI for geocoding addresses. I know we are not at the time. And then the second question I'll ask when Joe gets back, but if there's anybody that wants to chime in chat that if they're using AI for geocoding addresses and rematching without creating models. And Joe, and then Joe's back.
Yep, I just got on my phone while the computer's rebooting.
Okay. There was one other question here, and I asked the question for chat to answer, and I don't know if that'll happen. But the other question is, what about guidance on AI policies directed to consultants on government projects who may be using AI with their own set of policies and governance?
My suggestion to that would be that you would need to see what their policy is. What kind of governance, what kind of oversight are their models on-prem? Are they in the cloud? That you need to understand their oversight. Are they using an open source model, or are they, if you're using a consulting firm, I would like to think that they have their own on-prem system. So look at that. And then the only other thing is you need to review your your general IT policies and any kind of GIS policies that you already have in place, and to follow that structure. I'm not sure if I answered that question well enough.
Yeah, and I could probably chime in too. I mean, you really have to look at, we have that problem coming up quite a bit with terms and conditions and things that we look at for vendors and software and services that are offered. And it really, you can push back in a lot of ways to the folks that are on those projects to get them to comply with what your requirements are. I mean, especially as a government entity, it's really important to make sure that they are complying with the governance that you've established. And if it aligns that way, hopefully they're doing more and not less. But if they are doing less, then we always ask for them to update or comply with the contract that we're setting up. There's another question. Are graphics generators powered by large language models or something different?
They, I think that they are powered by that, but they are looking at the pixel and they are predicting the pixel as opposed to text. I actually, that is a good question. I don't actually know off the top of my head.
That might be something we can follow up on.
Yeah. And so in case anybody's wondering, oh yeah, so yes, image generators are increasingly powered by or integrated with large language models. Sora, I use Sora for several of the graphics. You know, when in the presentation, I use for the different graphs, that was Sora provided while I was interacting with my chat GPT. And that, so yeah, it is, I thought it was off an LLM. Yep. And it's an image output token. So what it's going to do is breaks up the image into tokens. And then it tries to predict what the surrounding tokens should be to make a comprehensive image.
And this other question, so there was two, and the one that I can go back to, that the question was, anyone using AI for geocoding addresses and rematching without creating models, which is one I asked for the chat in the chat. And then the follow-up question, how does it handle geocoding in another language that's a non-native, non-English language?
I would think that there are models out there that even ChatGPT, I bet you if you put Spanish in there, it would be able to understand that. You would have to give it the right instructions. And just like you would if it was in English. So yeah, I don't see any problem with it, you putting in, you know, a foreign language data set. Because that's one of the things, like the Geo AI in particular, one of the demonstrations that I saw about that from Esri, and it's on YouTube. It's like a 3 or 4 minute video if you find it, where they can just, the AI that Esri is putting in there can actually look at your attribute fields, see that text in some capacity, and when you say, "Hey, I want a map that shows a hotspot of crime, of violent crime," it can look at your data and predict which of your columns are the most relevant to that query. Especially if you have, you know, property crime, violent crime, you have different categories of violent crime. And if your metadata and your data dictionary are strong enough, it will predict that very well. It will create you a very good map based on that. So I don't see other languages being an issue.
I think that's all the questions we have so far. Is there any other questions? Please, again, use the Q&A tab to do so.
And I want to take this moment, just on a personal note, there there are a lot of people that are a little reticent. That we are not at Skynet yet. So let's be clear, we don't have Arnold coming to get us. But if you don't use the AI properly, it can seem that way sometimes. Um, there are some things out there that is of some concern to me, and some of that is called, a agentic AI, and that is when people are letting their agents, and create an AI agent to do tasks for them. So you can have it, and it's even built into some of the Gemini, you know, stuff already. You can set up tasks. Oh, respond to this email appropriately. That's kind of scary. And one of the things, and this isn't to scare anybody, but this is the reality of what we're living in with this AI stuff is. I recently read about how they had some. It was low level right now, but a hacker was able to get into a system using agentic AI where he gave the parameters and the instruction. All he had to do was a couple times hit yes or no to what the AI was asking him, and he was able to get into a system. He didn't have to code it. He didn't have to sit there and do the hacker stuff that we saw in the movies and stuff like that. If you remember the movie Hackers, dial-up modems get in there, all that stuff. He just let the agent. He set up a few things that he had to know as a hacker, but once he got in, he let the agent do all the stuff. It was low level. It wasn't high level stuff. It wasn't a super secure site or anything like that. But the fact that it is advanced that far already, and as I said earlier, technology moves exponentially, not linearly. And as the AI gets more powerful, more things like that are going to happen. However, and the one thing I did not get into, because this is a whole nother webinar, and it's a lot more on the technical side. When I said that GPUs are the lifeblood of, okay, I see that, Daniel. There is a chip shortage and there is a choking point in the chips, and that is Taiwan. So geopolitical maneuverings and that stuff will affect the AI world. It will affect computing world, computers in general, because as I mentioned earlier, they've stopped making a lot of making these chips available to um, some companies. Recently I read where there was one of the biggest components of these chips is silver, not so actual physical silver. There's only so much of that available, and the demand for that is so high that it cannot be met. And what we are seeing is you have like 5 or 6 companies investing in each other, promising infrastructure. I'm going to give you 300 million and you're going to build the infrastructure. And then that person that's building the infrastructure is going to give the chip maker 300 million. And it's very circular, but we have a choke point, the chip maker. And if that chip maker can't produce them at scale, AI doesn't scale, because you have to have that computing power. I said that at least a dozen times, the predictability at scale. You will top out if you don't have enough chips, if you don't have enough data centers. So that is another concern. There is an AI bubble. I'm not going to say it's going to burst this year. I'm not going to say if it's going to burst, but it is something to be cognizant of, especially for those that rely on AI too much. And I would dare say not too many people do right now, but I would caution anybody getting too deep into the weeds and make AI handle everything. Because if that bubble bursts, some systems will collapse.
So there's two more questions, and I think we might have time to get to both of them. But
Okay.
Thad has asked, what is the biggest success or accomplishments that AI has helped you with so far?
Um, for me personally, it allows me to this is going to sound very egotistical, but I get to have a conversation with myself. Somebody that is smarter than me in real time and can handle, for me personally, my ADHD. I jump track left, right, center. I'm crashing that train, but the AI doesn't care. Picks up right where I left off at any point. And that's what I need in my life to help me stay focused. I need somebody to verbally, proverbially, I type. I still can't talk to it. I am not there yet. But the ability for me to iterate my ideas at a very high level, it takes so much pressure off me. And that's personally why I love it so much.
Great. And the last question, which we may have to follow up since we only have a couple of minutes left, is currently our county government has AI blocked because they don't know how to deal with it. Any insights about gradual adoption to a local government?
Um, reach out, whoever that question was, please reach out to me. I think that's conversations I'm having here. And there are ways to introduce that. Briefly, I would say if you have an opportunity to use AI in your personal capacity, use it and show it to somebody in power, somebody that likes, and they say, hey, look what we can do with this. Let me help draft a policy. What are your questions? You need to get your county commissioners in front of somebody that can talk to it, somebody like me or somebody like John. I'm throwing you out there, John. Somebody that can speak to it and how it can be used appropriately and how policy can guide how it can be used.
Absolutely. And I'm happy to talk about our AI journey here because we did the same thing. We looked at blocking it first and then adopted it with a policy in place. But with that, again, thank you, Joe, for your contribution. It was amazing. You did a great job on the webinar. Appreciate all the insights. It's incredible. We are looking at doing another longer session sometime in September. And Joe, I'm sure you will be a major part of it. So with that, again, thank you all for joining. I really appreciate you all here today and looking forward to the next one.
Thank you, everybody. I appreciate your time and thank you for listening to me drone on for 2 hours.